Right, g'day guys. Welcome back to another week of Python. Today we're going to start a new new Python competition. In the past, we've been working on the OUCC, or the Australian Mathematics Trust Coding Challenge, or the Bebra's Coding Challenge. This time we're going to ramp it up a little bit. We're going to do some harder questions on the Australian Informatics Olympiad. Now the AIO, as it's called, is designed for kids from year 9 and above, but I have also got students who do this competition when they're in as young as year 7, because Python is a language that everyone can learn, and as long as you can type, you can do Python. So first you go into OUCC2.info. Go to this website and then you create an account. Okay, you need to create an account to log in so that you can track your own progress. There are lots of questions on this website, and we are going to go through them bit at a time, starting with the easy ones and then work our way towards the harder ones as we go along. I'm not sure how many questions we're going to do today, but we'll go through and see how we go. And I'm going to do this every Thursday. So if you go into, if you've created an account, then you click on problems. Even if you don't have an account right now, you can follow me and do this activity together, okay? This is how the AIO works. There are questions that are served as words, and then you have to create a Python file and upload it to see if you got it right or got it wrong. And then it will give you some feedback and tell you how correct you are. Okay? So we're going to start with these starter problems. And as you can see, there are hundreds of questions in AIO, starting from really, really simple ones to really, really, really hard ones. Okay? Some of them are designed to go on for half an hour or an hour. So we're going to do as many as we can when we do these live streams. Okay, click on Addition. Now this is the file. The Statement tab is where you actually see the question, and then down the bottom you might also see the solution templates. These solution templates make it so that it's a little bit easier for you to submit without having to work out all of the variables and the ways that you reference the different inputs. In OUCC, we do all of the test inside the browser, but for AIO we do it using your own editor. So if you have idle, which is Python, which comes with Python when you install Python onto your computer, then idle is great. Some people like to use Eclipse or any other kind of IDE. Okay. So we're going to download this Python solution template. Save link as. Save it into our downloads folder. And then we're going to have a read of this problem. So your task here is straightforward one. You are to write a program that takes two numbers and adds them together. The input will consist of two integers, a and b, separated by a single space. It is guaranteed that a and b are between 0 and a billion. We strongly recommend using the solution templates provided below. These templates will ensure that you handle the input and output correctly. So this is the easiest question. And even at this level, we have two integers separated by a space in our input. Now, referencing these inputs are exactly the same as if you would do it in OUCC. But let's have a look at our file. So over here, I'm going to press open and open up our addition file. And then you can see that it already has a little bit of boilerplate code up the top. And then we got a equals 0, b equals 0. And a and b is mapped to the string from the input. Okay. You may have also seen us do this in the past, where we say vars, for example, is equal to list map int input dot split. So that's how we would have done it in the past, and then we would get A to be equal to vars 0, and B is equal to vars 1. Yeah, so that's how we would have done it in the past. This is another way you can do it. It's a little bit more direct if you are okay with keeping everything in one line. Then we have answer equals 0. Of course, we need to add the numbers and store the sum into the answer variable. Okay, if you have a look at the submissions, it says 23 and 45. The answer should be 68. So that's, sorry, I didn't show you the stuff here. Okay, so over here, the question says 23 and 45 is the sample input. And the output should be 68. But when we are doing our solution, we can't just put 68 here. Because if we did that, then it only works for that one solution, that one example. So that is why we need to actually work it out. So obviously, to add these two together, all we have to do is answer equals A plus B. That's it. Okay? And then it will print the answer, and that is the output. We'll save the file, so by going Control S, and then you have a look at the browser again. Over here, up the top, we choose the source file that we want to input, go into Downloads, and then we're going to import the addition file that we just created. Make sure it says Python 3 over here, and then click on Submit. And then lo and behold, congratulations, we have scored our first 100% task. Okay? So you can see that it is very similar to OUCC, which is all of the questions that we've done in the last few months. But instead of doing everything inside the browser, we now do it in our own editor. Let's go back to the problems, and you can see that I've 100% a lot of these already, but you should have your questions blanked out, and then every time you answer a new one, it would say 100%. So congratulations, and I suggest you try your best to do these questions. Sitting or standing? Okay, let's have a look at this. A local musician is putting on a concert to raise money for charity. The concert will be held in the town hall, a spacious venue perfectly suited for such an event. There are R rows of seats, each containing exactly S seats. At most, one person can sit on a single seat. That is, two people cannot share a seat. There is a problem. The concert may have been overbooked. This means that if everybody who bought tickets comes to the concert, some of them might have to stand. Now, the musician has approached you, not for advice, but for the answer to the following question. If everybody who bought the tickets arrives and tries to find a seat, how many people will end up sitting and how many people will be standing? The first line of input consists of two integers, R and S, which is the number of rows and the number of seats per row in that order. It is guaranteed that R and S is between 0 and 10,000. The second line will contain a single integer between 0 and a billion, the number of tickets that have been bought. We strongly recommend that you use the solution template. Okay, so for example, if we have seven rows and 12 seats per row, then the number of seats in total will be 7 times 12. 7 times 12 is 84. And there are 100 people who bought tickets, which means that 84 people will be standing. 84 people will be sitting, because that's everybody in the seats. But then 16 people, which is 100 minus 84, will be standing. Okay? Keep in mind that the answer for the people sitting is not always going to be the number of rows multiplied by the number of seats. Because even though the musician said that they are afraid that they have overbooked, they could have been underbooked. They could have a number of concert goers that don't fill all of the seats. So keep that in mind. Let's go down here and download our Python template. And then let's open up idle again. This time I open up the sit or stand template file. It looks like I'm just going to save it over here. Sit and stand. All right. Sit or stand. Okay. So now this is the solution template for sit or stand. We got R and S and the number of tickets. So the number of people sitting right now is 0. Number of people standing is 0. So let's have a look at how we would solve this. So we're going to say total seats is equal to R times S. Okay? So if the number of tickets is less than or equal to R times S, that means that we are underbooked or exactly booked out. That means that the number of sitting is equal to R times S. And that's it. And the number of standing stays at 0. Else, if we have been overbooked, then we'll say the number of sitting is still equal to R times S. Oh, sorry. It's not equal to R times S up the top. I'm really sorry. So if we are underbooked, then that means that the number of people sitting is exactly the number of tickets. My mistake. Because if there were only 10 tickets booked for your 100 seats, then only the number of tickets will be sitting. Otherwise, if we are overbooked, then the number of sitting will be the full number of seats. Or we'll just write total seats. And also, we have total seats up here as well. The number of sitting will be equal to the number of total seats. And the number standing is equal to the number of tickets minus the total seats. Okay. Save that file. And then what about if we wanted to test this on our own idle here? You can do that by pressing F5. So you press F5, and then you enter in exactly what you need. Okay? So R, let's say it was, 7 rows, and S is 12. And the number of tickets is 100. So press enter, and then we'll print out the number of sitting is 84, and the number of standing is 16. Okay. So this is another really easy question to get started with. All we have to do now is go up to the top of our browser, choose our source file, which is the sit and stand file. Make sure that Python 3 is selected, press submit, and then see your 100% result. Let's do one more, shall we? Over here, we got mixed fraction. Mixed Fraction says, you are sitting at your computer surfing the internet when a chance forum post stirs memories of an idyllic past. There were so many ways of representing rational numbers back then. Percentages, decimals, and of course, the mixed fraction. There was always something so wonderful about mixed fractions, the way they quickly told you how big the number was, yet still conveyed the subtleties of the fractional part. Such elegance. You shed a silent tear for days long gone. These are really entertaining questions. In the task, you are given a fraction in the form of n over d, numerator over denominator, I would assume, where the d would always be between 1, but it's also bigger than n. Smaller than n. And d and n are both between 1 and a billion. Your task is to find the two integers a and b, where 0 is less than, so b is between 0 and d, and ad plus b is equal to n. You do not need to and shouldn't simplify the fraction. Okay, that makes things easier, because if we had to simplify the fraction, that would be crazy. The input will consist of two integers, n and d separated by a single space. It is guaranteed, yada yada. And then you can do the output of your mixed fraction. So 22 over 6 is 3 4/6, and we don't have to simplify. 49 over 7 is just 7, and you don't have to do any fraction. Let's go down to the bottom, download your mixed fraction link. And then go back into idle, and then we're going to load up mixed fraction. Okay. Now we got the numerator and the denominator. Now we need to compute a and b. What is a and b again? So if you go into our browser, so basically we just need, a is the whole number, b is the new numerator, and d is still the denominator. Okay, let's go back. So a right now is 0. So what is a? A is basically the numerator divided by the denominator, but we have to round it down. So a equals n /d. That means that this is a integer division. So we round it down automatically without importing the math blocks. The math libraries. B is the new numerator. The new numerator is whatever is left over, the remainder, when you divide the numerator by the denominator. So how do I find what's left over? We use modulus. B equals n mod d. Okay? So if b is not equal to 0, then we print a. But then we also need to print out the new fraction. So the string of b plus a slash plus the string of d. Else, we just print a, which is the whole number, because there is no remainder. Okay, I'll test this out. Oop. Haven't fully closed my brackets. Let's try it again. So 49 and 7 becomes just 7. That's correct. Run it again. 22 over, 6? Oh, something not right. Line 10, 22 over 6. Oh, because I had the slash there. That's wrong. So we go 22 space 6 is 3 4/6. Okay, fantastic. This looks like it works. But in AIO, just like in OUCC, we don't know what the actual tests are when they give you your score. So let's save the file, and then let's go back into our browser. Go up to choose our source file again, put in our mixed fraction file, submit, and there we go, 100%. All right, I hope you enjoyed our basics for getting into AIO for today. If you like what you see, make sure you comment below and tell me what you think as well. I will see you again next week on Thursday. Bye-bye.